and I thought we'd try something different. I'm gonna go around the room, ask a few questions here and there, I think. So it's a bigger version of something that we've seen before. And so that your packet has where you need to fill in some of the blanks there, I think. So I see people put matter up there. So we'll start over here with you, Kate, if you don't mind. So matter can either be what's left or right. Remember? This one has two words. It's starts with letter P and then starts with letter S. Mm-hmm. If something isn't a mixture, it's pure substance. Pure substance, exactly. Ding, 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 ding. Okay, Hannah. So what about if it's not a pure substance? It must be starts with letter M. Mix. Very good. Mixture. Perfect. And then Mackenzie, down here at the bottom, if it's a pure substance, we have two choices. If it's atoms of the same type, we call it letter E.
Electron?
No, bigger than that. Periodic table has all sorts of letter E.
Oh, elements.
Elements. Yep, very good. Elements. And today we're going to be talking about putting those elements together, like the water molecule has 2 hydrogen and oxygen, to make something that starts with letter C. So, here. Starts with letter C. Compound. Compound, very good. Okay, Jasmine, there's 2 types of mixtures. One is like the well-mixed mixture, and they both start with letter H, unfortunately. Homogeneous, perfect. So that's a homogeneous mixture. And then back to you, Ian. What if it's chunky? It is a heterogeneous mixture. Perfect. Very good. So today we're going to kind of focus on compounds. Talk more about those. Okay. Since we talked about elements, now elements can be, you can do a chemical reaction to build elements up to make a compound, or you can take a compound and break it down into its elements. Okay, so in order to be a compound, it needs to have atoms of at least 2 different types. Makes sense. That are stuck together with chemical bonds, and we'll talk about the chemical bonds a little bit, in a repeating unit. And so you've probably seen these before. These are formulas down here to show how many atoms of each type of element there are. But I want to kind of pick on, let's see, I'll pick on calcium sulfate. So in calcium sulfate, how many calcium atoms are there in a repeating unit? What does the formula say? Well, in a water molecule, okay, we're going to go around the room. So I'm going to go up to you, Kate. Let's pick on a water molecule. How many hydrogens are there? 2. Very good. Hannah, how many oxygen atoms in a water molecule? 1. Perfect. Mackenzie, we're going to switch. We're going to jump down to calcium sulfate. How many calcium atoms?
1.
Just 1. Yep. Nadira, how many sulfur atoms?
1.
There are 1. Yep. Now there's like an implied sort of little subscript 1. If there's no number there, it's implied 1. Perfect. So I'm going on to you, Jasmine. How many oxygens? 4. Perfect. All right. Now I'm going to set this up, Ian, and then I'll ask you how this goes, because I want to pick on magnesium nitrate just a minute. Now, it's kind of in math, like where if you have 2, I don't know where to put this, 2 times 6 plus 3, okay, that means that you take the 6 plus 3 and you take 2 of those. Okay? This thing right outside of the parentheses kind of means the same thing. So we have an NO3, which the name for NO3 is nitrate, and we have 2 of those. So that's what that means. So sometimes I'll take it and I'll draw it out and I'll go Mg and I'll kind of go my NO3. Here's my NO3s. Okay, so Ian, how many magnesiums do we have?
1.
We have 1. Perfect. All right. Kate, how many nitrogens do we have?
2.
We have 2. Perfect. And then on to you, Hannah. How many oxygens do we have?
3.
No, it would be 3, but notice we have 2 of those. 6. Yeah, very good. We have 6 oxygens. Perfect. So we use formulas to say what's in a compound, how many atoms of each type of element there are. Like you saw on the slide a minute ago, the compounds are made up of, you can use a chemical reaction to go back and forth. So, which is kind of fun. It's like magic. Like I said, next week we'll be doing some chemical reactions. But you can take elements, atoms of one type of element, and you can do some sort of chemical reaction, CHM, RXN for reaction, and you can make a compound. You can also take a compound and do some sort of chemical reaction, and you can break it down into its elements. So that's kind of fun. Okay, so compounds are expressed by writing the repeating unit as a chemical formula. We just talked about. And like I told you, if there's no subscript, like CO means 1 carbon and 1 oxygen. Now, one thing about it is that, and I probably rushed through this with regard to elements, but of course, C is carbon and O is oxygen. And we always use capital letters to represent them. For a good reason. Actually, if we had, anybody know what CO is? Like little o? In chemistry, it's on your periodic table. Cobalt, yep, that's cobalt. So we always have to use an uppercase letters for elements when it's just one letter, or the first letter will always be uppercase. All right, so there's 2 types of compounds. So I'm going to kind of take this compound and I'm going to break it out. And the 2 types of compounds are molecular and ionic. So if somewhere in your notes, this might be helpful to kind of organize things. So with regard to compounds, we have molecular and ionic. We use chemical formulas for both of those compounds, but they're kind of different cats. So I'm going to kind of make a division here, and I'm going to kind of say some differences between these 2 types of compounds that have atoms of different elements that are stuck together. So first off, if it's a molecular compound, then the repeating unit is called a molecule. That's its name. So, like if you say a repeating unit of a water, we call it a water molecule. Just 1 oxygen and 2 hydrogens. Now, if it's an ionic compound, we call that repeating unit a formula unit. It has a different name. So an example of an ionic compound, I'll put up here, example is NaCl. What's NaCl? Salt, table salt. Yep, sodium chloride. Very good. An example over here, I already told you, I'll go ahead and say is H2O. Very good. That's 2 types of compounds. All right, so I'm going to try to dig out my periodic table. I'm losing things this morning, so no guarantees. But on your periodic table, see where were we? I can't remember who we left with. But I'm going to ask you, how do you know where the metals and non-metals are on your periodic table?
The jag.
The jag. Thank you. Exactly. So if you find the jag, if you find your periodic table, because you're going to want your periodic table handy to answer these questions coming up. think the problem with periodic tables is I almost have too many of them. Okay, so Jasmine, if you find the periodic table, because I can't find mine, find sodium on the periodic table and tell me if it's a metal or a non-metal. Oh, it is a metal. What's that? It's a metal. It is a metal. Very good. And so actually, under ionic compounds, I'm going to go ahead and put has a metal. Has a metal. Formula has a metal. I'm not going to say contains metal. How's that? Contains metal in formula. How's that? Final answer. And Jasmine said that sodium is a metal. Cool. So I know it's a subtle thing, but like I said, I'm going to ask you here in a minute, and I'm going to give you some formulas and ask if it's an ionic compound or a molecular compound. If it has a metal, it's an ionic compound. So over here, molecular compound, this is mostly just nonmetals bonded to other nonmetals. So I guess over here I could put only nonmetals, usually. So Ian, on the periodic table, which one did we just say we had more of, metals or nonmetals? You didn't bring your periodic table again? Okay, so the JAG, okay, Dara said the JAG, so the JAG's over here, and that's non-metal. So which one do we have more of?
More metals.
We have lots more metals than non-metals, perfect. So only the non-metals join together to make these molecular compounds. It's amazing. If you've heard of like organic chemistry or just organic things, and I don't think like organic vegetables fall under this category, but life, this is life over here. And it's just, I just find that totally amazing. Non-metals bond to other non-metals to make molecular compounds. And then see if I have this up here too. Yep. So for purposes of looking at a formula and saying, I'm looking at a formula, I'm looking for the metal to see if it's ionic, and I don't see a metal, but I see hydrogen. What is that? And for all intents and purposes, we're going to go with hydrogen as a non-metal. Okay? We'll count hydrogen as non-metal usually. H is non-metal for this purposes. Very good. So up to you, Kate. So we take hydrogen as a non-metal. Is oxygen a metal or a non-metal? It is a non-metal. So we have two non-metals. It's a molecular compound. Yep. Can't remember what else I say in here for this class. I get my classes mixed up sometimes. Okay. So we already said this one is molecular. So if you want to jot down molecular. So I'm not going to give you that one, Hannah. But I'll give you this next one. Thank you. This next one, carbon dioxide. So to me, I have to have a periodic table handy, and I have to find carbon and oxygen. And if they're a metal between them, then it's ionic. But if they're not, it's molecular. What do you think, Miss Hannah? I'm going with molecular. Yep, very good, molecular. So Mackenzie, ethane, C2H6.
Is it molecular?
It is molecular, very good. Wow, we've got 3 moleculars in a row. See what we got here, Nadira. Calcium sulfate, CaSO4.
Ionic.
She said ionic, yes. So if it's ionic, it must have a metal. Which one's the metal?
The calcium.
The calcium, perfect. I'm liking it. Oops, okay, Jasmine. Ammonium sulfide. I'm not going to do this one. I'm going to hold it to next time. This is one of the few exceptions. I shouldn't have this on this slide. This is so irritating. Actually, as it turns out, ionic compounds have cations and anions. And as it turns out, this guy, NH4, is a cation. NH4 is with a +1 charge. So that's ionic, sorry. But I'll ask you a different question, Jasmine, if that's okay. So, Jasmine, how many nitrogen atoms are in that repeating unit?
2.
2, perfect. Ian, how many hydrogen atoms are in this repeating unit?
8.
8, perfect. Kate, how many sulfur atoms? 1. Okay. So back to you, Hannah. What do you think? Magnesium nitrate, ionic or molecular?
I think it's ionic
You think? I think so too. Why is it ionic?
because there is a metal.
There is a metal. Very good. Metal makes it ionic. Perfect. Cool. And as I'm thinking, you know, what you guys are thinking about the subject, you're like, now why does it matter if it's molecular or ionic? You just have to take my word for it. It matters. One of the things is it just matters. Now, did you guys bring your calculators or your phones, whatever you use for a calculator? Because we're going to do some calculations here in a minute. Remember that decimal number, so I guess we're up to you, Mackenzie. So what is, well, we'll do it this way. I'll ask 2 questions. For each box, like if I look at aluminum, what's the 13 mean? For aluminum.
It's the atomic number.
It's the atomic number, perfect. It's the number of protons, perfect. Thank you. So Nadira, for aluminum, it has 26.982. What does that mean?
Mass.
Mass, perfect. And then mass in what units? Do you remember? Use. Awesome. Okay. So what she said is, we can add aluminum 26.982. One atom weighs that many U's, atomic mass units. So now we have this thing, we're just basically going to scale that up. In that if we want to know how much an entire molecule weighs, all we got to do is add those up. So sometimes in physical science you're like, don't make it more complicated than it is. And this is one of those. So you guys will do great with this. So let's see what that looks like. We'll do a few together. Let's see what I end up with. Jasmine, how many, well, I'll do it this way. You guys would tell me there's 2 hydrogen atoms. So Jasmine, how much does 1 hydrogen atom weigh? And you can use your periodic table. Very good, 1.008. And what would the units be? Use. Awesome. Okay. So back to you, Ian. I'll put 1 here because we have 1 oxygen atom. And how much does 1 oxygen atom weigh?
How much does it weigh?
Uh-huh.
15.999.
Yep, that's what I got. Cool. So, oh, units would be U. Sorry, naked number. All right. So all we got to do is add those up. Or multiply. I'm going to add. Oh dear, my battery's dead. So, Kate, can you help me out? I see her tapping in there. What'd you get? You go ahead and give me everything you got.
17.015064.
Cool. Oh, I'm wondering, because this is one that I committed to memory. I'm thinking, did you multiply your first number by 2?
Oh, I have, okay, yeah. 18.015.
18. Okay, cool. Very good. Thank you. 18.015. And then what would the units be? U. Yay. Okay. Let's skip down to calcium sulfate. So, Hannah, how much does, I'm going to put 1 for 1 calcium, and how much does calcium weigh?
40.07.
Thank you, very good. 40.078. And then on to you, Mackenzie. How much does, I'm going to put 1 for sulfur, and then how much does sulfur atom weigh?
32.06.
Perfect. Nadira, how much? I'm going to put 4 for oxygen, and how much does an oxygen atom weigh?
15.999.
Yay. Okay. And then, oops, sorry, I'll put my equal sign here. So, Jasmine, do you have are you tapping it in?
It's 136.134.
Very good. And what would the units be? Use. Perfect. Speaking of units, you kind of notice where I went into my, I think it's okay. Notice I didn't put the U's here, the U's for the weights. I just put it at the end. I'm afraid I've just done too many of these, and that's the habit I'm into. So if you have that habit, that's fine too. Okay? All right. Any questions about this? So the next slide is the homework that's just like what we just did. So you guys did, and one of those will be on your test, so that'll be due on Friday. Fabulous Friday. So I'm gonna go ahead and play this video before we talk about this. I didn't fully preview this video, but I think it's a good one. From here, that solid line versus the dotted line. Okay, so these right here, as I've drawn them, are what we call, and it's on the slide here, covalent chemical bonds. This is a covalent, I'll just put, yeah, I'll put chemical bond, CHM for chemical bond. And the thing about covalent chemical bonds, and he said it a minute ago, is that electrons, I'll put the symbol E with a superscript negative, are shared. Okay? Covalent chemical bonds, electrons are shared to make that. Well, over here between the Na and the Cl, I'll draw a little line there, and I'm going to say that this is an ionic chemical CHM bond. And I'm going to say here that electrons, E superscript negative, are transferred. For those of you who have your periodic table marked it the other day, at the top of the column where sodium is, what type of ion did you mark? I think we're about up to you, Kate. What do you think? The top of the question? I know. I was frustrated. At the top of the column for sodium, what sort of ion did you put?
Positive charge?
Yep, a positive. Plus or +1. Perfect. Okay. Hannah, did you have the one for chlorine? At the top of the where chlorine is, look at the top of the column. See what sort of charge it forms. You have -1, and that's totally right. Okay, so basically, in order for that chlorine to become a -1, an electron is transferred from the sodium to the chlorine. 1 electron transferred, and it was just kind of like the guy said. I can't think of his name. Anyway. Like he said, that once you have, now after electrons transferred, something that's negative, something that's positive, then they're going to want to come together because they're oppositely charged. Okay, and that makes that ionic chemical bond. So, like I said, metal gives up an electron. In this case, the metal is a sodium, becomes positively charged, in this case a +1. And the non-metal accepts an electron, which in this case is the chlorine, becomes a -1 anion. And then they're attracted to each other. So I was trying to see if I had this in my notes, right? So one more thing I'm going to add to, and I think that might be about it for our kind of comparing the two types of compounds, but it's important. For molecular compounds, I'm going to say all, I ran out of room at the bottom, but okay, all bonds, all chemical bonds, all CHM bonds are covalent. Are covalent bonds. Electrons are shared for everything if it's a molecular compound. For any atoms connected together in that molecule, electrons are shared. And over here, and it's kind of a contamination issue, over here, then we could say has at least one ionic bond. Ionic bond. There are a lot of ionic compounds that have like a lot of covalent bonds when the atoms are stuck together with sharing electrons, and then it just takes one situation where you have a cation and an anion to make it an ionic compound. Cool. Well, actually, he talked about this a little bit. He talked about electronegativity. I think we'll leave this until, let me double check, yeah, because there's a couple seconds. Yeah, let's get a running start at this on Friday. So this is where we'll pick up. But see you tomorrow, right?